Correlation. We've got maths teachers working in different towns, and we've also got the number of burglaries. So what we need to do is go on our calculator, go down to statistics mode, which is here. We need to press number 2, which is bivariate data. So we've got two columns there, x and y. So we just need to fill out the x's, so 35, 42, 21, 55, 33, 29, 39. Let's not do the last one because that one's unknown. Right up to the top on the y's, we've got 30, 28, 21, 38, 35, 27, and 30. Okay, and then what we do is we hit the option button, and then we click on regression calculation. That should do the job. Perfect. And R, that's the value for the product moment correlation coefficient. That's what it's called. Okay, so we write A, just simply, it's a 1 marker. R is equal to 0.7922. That will do the job. Okay, great. Hence, interpret the value of the PMCC in the context of the question. And that would be that there is a correlation because that number is close to 1. It's a positive correlation as well because it's close to 1 as opposed to -1. There we go. So I said, as the number of maths teachers increases, so do the number of burglaries. It's a positive correlation. Okay, part 3 asks us to do a hypothesis test for correlation. So we start that off by saying H0, and then we use the letter rho, which looks like a P, is equal to 0. That means there's no correlation. And we're testing here that there is a positive correlation. So therefore we need to test, we need to say that the rho is greater than 0, like so. Okay, so the next thing to do is we need to find our critical value. So I'll go to my tables. Okay, so here is the tables, and we are testing at the 5% level. So I need to use that column, and we have, even though we've got 8 bits of data, we actually only use 7 because we use from A all the way to G. We didn't use H. We don't actually know that bit of data actually. So yes, so 7. And going along, we've got, this is our critical value. So I would write the critical value is equal to 0.6694. And then I would always remember to find the magnitude of the PMCC. Just in case it was negative, we need to take the magnitude. In this case, we don't really need to because it's positive. But just remember that we're always looking for the magnitude of the PMCC. And that is greater than the critical value, which is kind of our threshold. So that means that our data is more correlated than the threshold. So therefore I can say that there is significant evidence of a positive correlation because it meets our threshold, it goes past it. Okay, great. Next, it says comment on the statement the maths teachers are likely to be responsible for the burglaries. Well, that's just ridiculous, isn't it? So that's not the case because what we should know is that correlation does not imply causation. And therefore we can say that the statement is unlikely to be true. Okay, great. Okay, now the next part asks us to use our linear regression model. Okay, so if we go back to the calculator, you can see here that it actually gives you the linear regression model, which is essentially the line of best fit if you were to plot these this bivariate data. And it gives it in the form y is equal to a plus bx. So that is y is equal to 15.1 plus 0.408 x. Great. So that's that done. We don't need you anymore. So we can use this now to estimate what the value of k is. Because if we go back up, we can see that k is unknown. It's a y value, which we don't know what it is, but we know it has a corresponding x value of 40. So we can say that y is equal to 15.1 plus 0.408 times by 40, and that's going to give us a value of approximately 31.42. Perfect. And all the y values were given to the nearest whole number, as we can see here. So I would make sure that I would do that as well. So that's 31. Perfect. Okay, question 2. We've got measures of central tendency, so like data, mean and standard deviation and whatnot. So we have here a frequency table, and a histogram is drawn representing this data. The bar representing logs with lengths between 27 and 30 has a width of 1.5 centimeters and a height of 4 centimeters. So calculate the other widths. Okay, so that means that it has an area equal to 1.5 multiplied by 4, which is equal to 6 centimeters squared. Okay, so 15 logs represents 6 centimeters squared on my histogram, because the area is the frequency. Now the next bar which we need to look at is between 20 and 25, and we can see that has a frequency of 35. So I can scale this up to find what that area should be. So I would just divide this one by 3 and then times it by 7. So it's going to be 7 over 3 as what I'm going to multiply by. So I'm going to do the same over here, multiply by 7 over 3. That gives me 14 centimeters squared. Okay. Now we also know about the width. So the width of this one was 1.5, and that represents a width of 3. So that means for every one of these, it's 0.5 along on our histogram. So the one that I need to inspect now is this. So that means that that one will be 0.5 times 5 width. So we know that the width will equal 2.5 centimeters. And then the height, well, the width and the height need to multiply to make 14. So I just need to do 14 divided by 2.5. That gives me a height of 5.6 centimeters. Okay, now it says use linear interpolation to estimate the median of L. Okay, well, we know that there are 88 logs in total. So we are looking for the 44th log. That will be the middle one. So that will occur in this row, because we've got the first 19, and then if I add on 35, that's going to take me past 44. So I know that the 44th log is in that row. So what I do for linear interpolation is I write the width is 20 to 25. The number of logs in here is from 19 up to, add on 35 will give me 54, and I'm looking for the 44th log. So the fraction 44 minus 19, that is this sort of gap, out of the total width, which is 54 minus 19, is equal to the median, which is here. The gap between the median and 20 as a fraction of the whole width should be the same. So 25 minus 20. So that's the formula that I set up. And then it's all about solving that for m. When I solve that for m, I get a value of 23.57. Okay, perfect. Okay, part C. Jill can only use logs in her stove a maximum length of 26 centimeters. So she estimates using interpolation that X logs will fit into her stove. Okay, well, it's only a one marker, so I don't think we need to use like full interpolation. I think it should be nice and straightforward. And the fact that 26 is perfectly halfway in this interval means that half of that 16 will be less than 26 and the other half will be greater than 26 by estimation. Of course, it's not necessarily like that, but again, it says to estimate using this method, so that's fine. So there's going to be 8 basically, which are less than 26 in this group. So we just need to do 19 plus 35 plus that half of 16, which is 8. So that gives me a total of 62. Okay, part D, it says that Jill randomly selects 4 logs from the bag. Using X is equal to 62, find the probability that all 4 logs will fit into her stove. Okay, so that means that it's going to be, there are 62 that can out of 88. But then when she takes that 1 out, then there are now only 61 out of 87. And then again, there's now 60 out of 86. And then there are 59 out of 85. So that's the calculation we have to do to get successive logs which are all going to fit. And that calculation is 0.2392. Lovely. Okay, part E. It says that the weights of the logs in the bag are coded using this code y is equal to 0.5x, sorry, w minus 255, and summarized by all of these y values. Calculate the mean of w. Okay, so what we're going to do first is we're going to calculate the mean of y, so y bar. So the coded data we're going to use, and the mean is equal to the sum of the y values over the number of values. So the sum is 924, and that's over 88, and that's going to give me a value of 10.5. And then we need to recode that. So for a mean, then that is affected by multiplication, and it is also affected by any addition or subtraction. So it's essentially, we're just going to plug it into that formula. So I'm going to use that the mean is 10.5 of the mean of y, so that I can rearrange to find the mean of w. So I'm going to add 255, which is going to give me 265.5, and then I'm going to divide through by that 0.5 to rearrange for w, and that gives me a value of 531. Perfect. Okay. Let me grab some space. And then let's do the next part, which is the variance. Okay, so the formula for the variance, I'm going to work out again the variance for the y. So that will be sigma squared y, and that is the sum of the y squareds over the number of terms minus the sum of the y's over the number of terms squared, sorry. Okay, so that would be that number which is given over 88, and then minus, well, we actually know what that is inside that bracket. That's the mean, which was 10.5 squared. Okay, so we can work that out, and it gives me a value of 35.909. Okay, so we've got the variance of the y values. Now, the way that standard deviation is linked to coded data is that the standard deviation of y in this case would equal 0.5 the standard deviation of w. So addition and subtraction does not affect the standard deviation or the variance, and that's because if you just add and subtract the same amount to every data point, it doesn't spread it out anymore, it just shifts it along. But we have to be very careful here because we need to square each term in order for us to now apply the variance as opposed to the standard deviation. So this is the formula we need to use. So I do 35.909, and that's equal to 0.5 squared multiplied by the variance of w. So I need to divide by 0.5 squared, and in doing so, that gives me a value of 143.6, and that's going to be my variance of w. Okay, we've got a probability question here, and it says write down the value of the probability of A. Okay, so probability of A is basically everything inside the A circle here, and that is going to be 0.13 and 0.12, so that is 0.25. Lovely. Okay, the next one, find the probability of A given you're in B. So let's say you are in B, what is the chance that you are also in A? Well, it's 100% because B is completely contained in A. So the answer to that is 1 whole. Okay, and the next one is probability of A given you're in C. Well, the chance of me being in A if I'm over there in C is 0 because they're mutually exclusive. So that one's 0. Okay. And now it says, given that the probability of B and D is 0.7, and the probability of C given D is equal to 3 over 5, find the exact value of Q and the exact value of R. Okay, tricky. So first off, let's set up as many equations as we can. Let's use the first bit of information to set up an equation. So probability that you are not in B and you are not in D. So you're not in B and not in D. You're not in B and not in D. And you are not in B and not in D. So it's all those ones. So 0.13 plus P plus S is equal to 0.7. So therefore P plus S is equal to 0.57. Okay, that's a start, but we'll park that because we can't go any further with it. Okay, so now let's look at this one. It's the probability of C given D. And the way that we can write that is the probability of C intersection D over the probability of what's given, which is the probability of D. and we're told that's equal to 3 over 5. Okay, so let's first find the probability of C intersection D. So where does C and D intersect? Here at Q. So that is just Q over the probability of D, which is R and Q make up the whole of the D circle. Okay, so that's the R plus Q, or Q plus R. And that's equal to 3 over 5. Okay, great. But those two equations don't link at all. So that's still not going to get us where we need to go. So we need one more equation, I would suspect. And that one will be the fact that we know that everything adds up to 1. So I can say that 0.25 plus P plus Q plus R plus S is equal to 1, which means P plus Q plus R plus S is equal to 0.75. And we know that P plus S is 0.57, so we can sub that in down here, and we can use the fact that P and S make 0.57. Let's just grab some more space. Okay, so I know that P plus S is 0.57, so I can say 0.57 now plus Q plus R is equal to 0.75, which means that Q plus R is equal to 0.18. Okay, so now I can use that in my equation in the top right here. So I can say that Q over Q plus R, we know, is 0.18, is equal to 3/5, like so. So then we can multiply across to get Q. So when I put it into my calculator, I get 0.108. Okay, and now we can use that to find R, because we know that Q plus R is equal to 0.18. So therefore R is equal to 0.18 minus Q, which is 0.108. And that gives me a value of 0.072. Okay, great. Next part says, given also that the probability of B union not C is 5 over 8, find the exact value of S. So what is that then? That's B union with not C. So who's included there? If you're in B, then you're included. And also anyone who is not in C. So this guy here, and this guy here will all be in the union of B not in C. So we can write that out. We know that 0.13 and 0.12 make 0.25, plus R plus S is equal to 5/8. And we know what R is. R is 0.072, and that's equal to 5/8. So that's just a simple calculation, and that gives me a value of 0.303. Lovely, and we're done. Okay, this is an absolute beast question. It's a MADAS question. I can't imagine that you would get one this tricky, but perhaps. I mean, the one last year on discrete distributions was horrendous, but they did give it in like parts A, part B, part C. Well, this one has none of that, so it makes it even more hard. Okay, so what's going on here? Well, this is a distribution whereby certain values of x are obtained. Now, what we could do is we could set up a table to see kind of what this distribution is doing, which is probably the best thing to do. Okay, so we have certain x values. So the chances are 1, 2, 3, and 4. Those are the x values which you are options, and then we can work out what the chance of those x values are occurring. So the first one is just k. Now the next one, the probability of it being 2 is going to be a half of the probability of it being 2 minus 1, which is 1. So it's basically a half of the last probability. So it's a half of the last one, which was k. And then the next one again would be a half of the one prior, and then this one again is a half of the one just before. Okay. Now what do we know about discrete random variable distributions? Is that their probabilities will always add up to 1 because something has to occur. So what we can do is say that in this case k plus a half k plus a quarter k plus an eighth k is equal to 1. So how many k's have we got there? We have 15 over 8 k's when we add them up, so that's equal to 1. So therefore k is equal to 8 over 15. Okay, great. So now what we can do is we can actually find out what each of these probabilities are. So k was 8 out of 15. A half of that would be 4 out of 15, and then 2 out of 15, and then this last one will be 1 out of 15. So those are the probabilities. Right, now it says that we are going to take 3 independent observations of x. So we're going to run this game 3 times, and with all of our 3 outcomes, we're going to add them up, and that will be our final value, basically, which we're going to call y. So we need to work out that if y is an even number, determine the probability that y is greater than 9. So that basically means that we want to work out the probability that y is greater than 9 given that y is even. So that means, using our conditional formula, it's the probability that y is greater than 9 and y is even over the probability that y is even. So we're going to need to work out both of these two probabilities to find out our overall probability. So let's start with the easier one, which is that y is even. Well, how do you get an even number when you add up 3 numbers? Well, there's a few possibilities. It's either that we're going to get 3 evens, or we're going to get 2 odds and an even, which can happen in 3 different ways, like so. Okay, so what is the chance that we get an even come out of our x distribution? So evens are this one and this one. So an even will be 5 out of 15, which is a third. Okay, so it was a third times a third times a third. And what's the chance of us getting an odd? Well, of course, that would be the complement of the fact of getting an even. So that's 10 out of 15, which is 2/3. Okay, so this will be 2/3 times 2/3 times 1/3. What you'll notice is that because the probabilities don't change, they're independent, these 3 things down the bottom are going to be exactly the same. Because there's basically just 3 ways of doing the same thing, which is 2 odds and 1 even. So this will be 2/3 times 1/3 times 2/3, and this one will be 1/3 times 2/3 times 2/3. So this one will be 1 over 27, and this one will be 4 over 27, but there will be 3 times of them. So in total, the probability that y is even is going to be 13 over 27. Okay, perfect. Right, let me get rid of this working, and then we'll look at the probability of it being even and it also being greater than 9. So what outcomes can we obtain that are even and greater than 9? Well, we could obtain a 10, or we could obtain a 12, couldn't we? Let's start with how we could hope to obtain a 10 by adding up 3 of these x values. So we could get a 4 followed by a 4 followed by a 2. Now that can happen 3 different ways, just a bit in the same way that with the odds and the evens. This can happen in 3 different ways, because it could be a 4, a 2 and a 4, or it could be a 2, a 4 and a 4. Okay, so what are the probabilities of this? So let's just do 1 and then times it by 3. So a 4 is 1 over 15, another 4 is 1 over 15, and a 2 is 4 over 15. Perfect. Okay, I'll work that out in a minute. Let's just find now the other way that we could get a 10. Maybe this question was too hard. Oh, I'm sorry. We could get a 4, a 3 and a 3. And again, that can happen in 3 ways. So 3 times by, this question's too hard, sorry. 1 over 15 multiplied by 2 over 15 and a 2 over 15. Okay, we're still not quite finished though. Because you could also get a 12. Now there's only one way of getting a 12, and that is getting all 4s. So that will be 1 over 15 times 1 over 15 times 1 over 15. Okay, I need to go to my calculator to work these actually out. Okay, so when I work these out and then add them all together, they all sum to a total of 1 over 135. Okay, so going back to this conditional probability, I've just worked out here the probability of greater than 9 and even. That's 1 over 135. I need to divide that by the probability of it being even, which we said was 13 over 27. And that's going to give us our final answer of 1 over 65. If you got that right, well done. Okay, Superbounce is a manufacturer of tennis balls. It knows from past records that 10% of its tennis balls fail a bounce test. Find the probability that from a random sample of 10 of these tennis balls, at least 4 fail the bounce test. Okay, so what we would like to do first is write a distribution. And that is that we are having a sample of 10, and that the probability of fail is 0.1, which is independent of the previous tennis ball, and also there's only 2 outcomes, fail or success. So we can use the binomial. Okay, so I need to find the probability that x is at least 4, so that means that we want greater than or equal to 4, like so. Okay, I'll go to my calculator to do that, and we will need to go to a distribution, binomial CD, variable, and we actually need x to be 3, n to be 10, and p to be 0.1. Okay, because this is equal to 1 minus the probability that x is less than or equal to 3, which is exactly what we now know. So it's 1 minus 0.987 2, and that gives me a value of 0.0128. Perfect. Okay, next part says more than 1 but fewer than 5. Okay, so I need the probability of more than 1, so that will be 2 or more, but fewer than 5, so we can't have 5, so that will be less than or equal to 4, like that. Okay, which is the probability that x is less than or equal to 4 minus the probability that x is less than or equal to 1. Okay, so in order for us to do this, we're going to need again to go to our distribution. Whoops, where is it? There it is. And we've got that already set up. So we need 4, which is 0.998, and then we need to go back again and we need to do 1. I need to take that away. So that is 0.7360. Perfect. And when we do that, we get an answer of 0.2623. Lovely. Okay, so next, the managing director makes changes to the production process and claims that these changes will reduce the probability of its tennis ball failing the bounce test. Okay, after the changes were made, a sample of 50 tennis balls were tested and it was found that 2 failed the bounce test. Test at the 5% significance level whether or not the manager's claim is supported. Okay, great. So we can say H0, the probability, the historical probability is 0.1, but we are testing that the failure rate has reduced. So that means that we are doing P is less than 0.1, which is much easier when you're testing for the lower tail. So that's great. And we are going to set up a distribution which has 50 trials, and we're going to assume the old probability of 0.1. And then we're going to look at our test statistic, which is 2. And we're going to work out the probability that 2 or less than will have occurred. So the probability of less than or equal to 2. Because anything less than 2 would also strengthen the claim. So it's not just 2 that we find the probability for, but anything as well which would strengthen the claim. And just again, like if you are doing it this method, like not the critical region method, then this symbol here is less than, and then this one is a less than or equal to. They always point in the same direction. Okay, so we need to go to our calculator, and we need to go to 2, like that. Perfect, and that is that's wrong. That's what it is. That is huge. That is wrong because I've used the old sample size. This is a different sample of 50, and that is more like it, a lower probability, which gives me this. And then we need to compare that to our significance level. Well, this is much bigger than our significance level. Okay, and that means that it is likely to happen using the old probability, like we did. We used the old probability of 0.1. So this occurrence was likely to happen with the old probability. So there's no reason to suggest that something has changed because it's likely to happen. So therefore we say that there is insufficient evidence to suggest a change. Insufficient evidence to suggest the failure rate has reduced. So we always have to put a bit of context in. So therefore, that is the same as saying that we will not reject H0. Perfect. Okay, next part, it says that in a random sample of n tennis balls, so we don't know how many were taken, it is found that none failed the bounce test. Okay, so that means that, yeah, none failed. And as a result of this sample, the claim is supported. Okay, so if the claim is supported, it means that the chance of that test statistic happening was so small, it was below 1%, that we must say that it can't have, it was just so unlikely to happen that there must be a change in the overall probability. So the probability that x equals 0 is less than 0.01, because none failed the bounce test, so that's probability that x is equal to 0. And again, because it supports the manager's claim, it means it must be below the significance level. Okay, now what happens then if none of them fail? It means that all of them passed, which means that every single one would have passed. So we'll be doing 0.9 times by 0.9 times by 0.9. However many times we need to do it is to however big the sample is. So that is n. So to the power of n is less than 0.01. Okay, so we can take natural logarithms of both sides, or log of both sides, doesn't matter, and the n can come down from the power, like so. And then we can divide through by ln 0.9, but be very careful because ln 0.9 is negative, because the input is less than 1. And when you divide through by negative, it flips the sign over. So important to check that when you do divide by a logarithm like that. And this gives me a value of 43.7, which means that n must be 44, because obviously it has to be a whole number because it's the number of sample, it's the sample size. Perfect. Okay, we have got normal, and it says that we don't know the mu or the standard deviation. So we need 2 bits of information. So luckily we do have that. So I'll write that x is normally distributed mu and sigma squared. And we're also told that 5% of his weekly miles are less than. So for normal questions, I always like to draw just a little bell curve like this, just to get visualize what's going on. It says that less than, so 5% are less than, 850, so that 850 goes there. And it says that 1%, so that area there is 1%, is exceeds 960. Okay, so what we're going to do is we're going to find 2 z values, where z is the standardized normal distribution, which has a mean of 0 and a standard deviation of 1. So I go to normal, inverse normal, and I need an area to the left, because this always is to the left, of 0.05, and sigma 1 mu 0. Okay, so I get this first z value is minus 1.645, and the formula for the z distribution is, what's the formula for the z distribution? It is x minus mu over sigma. Yes, it is. So the x value is 850 and minus mu over sigma, like that. Okay, so now I need to do a second equation. Now this time, the area to the left of the orange value is 99%. So again, the inverse normal always gives you the area to the left, and in this case, because we've got 1% to the right, it's the same as 99 to the left. Okay, so that gives me my Z value there, which is 2.326, and that's equal to 960 minus mu over sigma. Okay, so now what I could do is I could rewrite this by multiplying through by sigma on the bottom, which gives me this, and then adding the mu over as well gives me this. And then I could do the same on here, and that will give me mu plus 2.326 sigma is equal to 960. Okay, so this is just a set of simultaneous equations which I'm going to solve. I can do that on my calculator. So equation, simultaneous, two unknowns, and right, there we go. I just set them up. So press equals. Great. So that first one is mu, and that is 895. Does it say to the nearest mile? So do 6, and then the next one is okay. So that's 27.7, which is approximately 28 to the nearest mile. Okay, part B, and we are hypothesis testing, and it says that the rep believes that the value of mu is much lower than the one found in part A, and based on a random sample of 4 weeks whose mean mileage was 863. Okay, so we start off with our null hypothesis, which is that mu is equal to what it was before, which is 896. And the claim is that mu is smaller, it's much lower than, is what we're told, 896. Okay, so the distribution we're going to use is a sample distribution, which we notate like this. It's a normal distribution, and we're going to use the old mean, or should I say the population mean. And we are going to change, though, the variance. So the variance was 28. No, it wasn't. The standard deviation was 28. So the variance is 28 squared, but we divide it by the sample size, which is 4. Okay, so that is the distribution we're going to use. Now, what we need to do is we need to figure out what is the chance that this test statistic occurs, or not just that particular value, but anything less than, which would also strengthen our claim. So the probability that from the sample distribution we're going to get a value which is less than 863 needs to be calculated. So we're going to go to our calculator and we're going to go into this distribution. And we're going to go for normal CD. Lower, I always recommend just doing a really big negative number. That will cover off all bases. Yeah, okay. Upper bound is, well, 863. And the standard deviation is the square root of 28 squared over 4. Perfect, because remember it's the variance inside that distribution, so we need to take the square root of it. And mu we said was 896. Okay, great, that is a small number. That is 0.00921, which is approximately 0.9%. And that 0.9% is smaller than our 1% threshold. So what we're saying there is that this is so unlikely to happen. This statistic here, this test statistic, is so unlikely to happen that surely it means that mu must be much lower than we have used in our distribution. So how do I write that? So I'm going to say there is enough evidence to support the rep's belief, and therefore we need to reject H0. Okay, question 7, and we've got the probability that a person completes a particular task in less than 15 minutes is 0.4. So this looks like a binomial because you either complete it or you don't. So I'm going to write that x is binomially distributed, and in this particular event, we've got 20 people, and the chance of them having success is 0.4. So it's asking me to find the probability that x is between and including 5 and 8. So if you think about what numbers would actually satisfy that, it would just be 5, 6 and 7. So what I'll do is I'll do the probability of less than or equal to 7. So that includes 7 and all the ones before it, and then subtract the probability of less than or equal to 4, and that will just give us 7, 6 and 5, which is perfect. That's exactly what we want. Okay, so I would go to my calculator without trying to spend too much time doing it. I will show that the binomial CD is what you want. You want variable, you want x to be 7 in this case, and you want n to be 20, and then you want p to be 0.4. So you press that and you get that's 0.4159, and then you need to do the same for 4 as well. So you go back, you change that to a 4, and that is 0.0509, 5, whatever. And then that will give you an overall answer of 0.3649. Okay, perfect. So that was part A. Now this is part B. Okay, so part B, and we've got a random sample of 140 people this time. It says using a normal approximation, the probability that fewer than n of these 140 people complete the task in less than 15 minutes is given as this, to 4 decimal places. Okay, so the binomial distribution that we would want to set up would be 140 people, and again the probability of success is the same as it was before, because it's the same task, doing whatever the task is in less than full 15 minutes. Okay, so if I want to approximate that, then I can use a different distribution, let's just call it W, which is normally distributed, and the approximation formula is NP for the mean, and it's NP times 1 minus P. Okay, so that means that W is normally distributed, so NP means 140 times 0.4, which gives you 56, and then multiplied by 1 minus P, which is 0.6, and that gives you 33.6. Okay, so that's my distribution, and it says fewer than n of these people, and because it's a normal approximation, we're going to have to use the continuity correction. So let me just explain how that works. So let's say, for example, this question said fewer than 20. Well, that would mean that the what we'd look for is the probability that y was less than 20, but not equal to, because it says fewer, so it has to be less than 20. And for binomial, that's the same as saying y is less than or equal to 19. Okay, but when we approximate with the normal distribution, because the normal is continuous, it could take essentially like non-integer values. So we've got to think about what is the biggest number we could possibly use here, which would actually still round to 19. So that would be the probability that the normal distribution would be less than or equal to, it doesn't actually matter for normal distribution, 19.5. Because 19.5 technically you could say it rounds down to 19. So that would be the kind of maximum value which would still be within our threshold. Okay, So what about this question then? Because this question says not fewer than 20, it says fewer than n. And the number that we came up with for 20 was 19.5. So the number that we'll come up with for n will be n minus 0.5. So we are looking for the probability that w is less than n minus 0.5. Okay, right, so what to do next? Oh, we're told that probability, aren't we? We're literally told it. It's 0.0239. Lovely. So what we're going to need to do is we're going to need to do a z distribution. So that's 0, 1. And we're going to need to find the z value which represents the area of 0.0239 in the lower tail. Okay, so here we are, inverse normal and the z distribution. So if I click equals on this, okay, that'll give me a z value of minus 1.979. And the formula for the z values is x minus mu over sigma. So that would be our x value is n minus 0.5. Our mu is 56. And our sigma is 33.6 square rooted. And that's equal to this z value here. Okay, so we can multiply up to the other side. And this gives us minus 11.47. And then we can collect these up, can't we? That's minus a total of 56.5. So add on the 56.5, and that gives us a value of 45.03. So the answer is n is equal to 45. Bosh. Just to confirm, I mean, the answer is 45. It's just a rounding error as to why it's not exactly 45. Because remember, they give us the probability to 4 decimal places, so it's not actually going to be bang on the actual value. But yes, the answer is 45. Okay, over to mechanics. We've got 2 small children. They're running a 100-meter race, and we've got one that accelerates up to 4 and then maintains that speed, and the other one accelerates at 1 for t seconds, then maintains constant speed. They finish at the same time, and we need to sketch a graph. Okay, so let's draw this as clearly as we possibly can. Okay, that looks good. So put t there and put v there. Now let's start with the first person. That they accelerate not as fast, or not as quickly, should I say, as the second person. So their first line won't be as steep. So let's draw this person in light blue. And let's say that they go like this. And then they finish off like that. And let's say that is 4. Okay, now the next person, they start off by, they increase their speed quicker than the other person. So they don't need to get to such a fast speed in order to complete the race, because they've started off by increasing their speed well, faster really at the start. Okay, and again they finish at the same time, so right there is where they're going to finish. And now it says, I think what we also need to do is just mark here that this is T, capital T, like that. And we've also got 4 on there, So that's good. Oh, another thing to note as well, because they're accelerating at 1 meter per second, that means that their gradient is 1. So this value for t down here will also be the y value as well, because essentially that line is a gradient of 1. So that's like y equals x if you were. So those two are going to have the same numerical value. Okay, and now it says find the time taken by, who's that? That's the blue one, to complete the race. Okay, so I think what I'm going to need to do here is a SUVAT, because we know that for the first part they're accelerating at 0.8. We know they start at 0, and we know that they reach a velocity of 5. So it'd be interesting to know what time they do that in. So we can use v is equal to u plus at for that. And that will be 4 is equal to 0 plus 0.8t. So dividing through gives me that t is equal to 5. So right there at that point, that is 5. Okay, so now what we can do is we can use the fact that we know the total distance of the race. So this blue shape is a trapezium, and the formula for a trapezium will give us the area. The area under the graph will give us the total distance. So the area of 100 is equal to the formula for a trapezium, which is a half. The two parallel sides, which is the total time. So that distance there is the total time of the race, which is what we're looking for. And this distance up here is the total time minus 5. So it will be the total time plus the total time minus 5. So we add the two parallel sides, and then we multiply by the gap between them, or the height of the trapezium, which is 4. Okay, great. So solving this, timesing by 2 and then dividing by 4 gives me 50 over here, and then collecting these up gives me 2t minus 5. So 55 is equal to 2t, so the time is equal to 27.5 seconds. Okay, perfect. Okay, part C has asked me to find capital T, so I need to look at now the green trapezium. So again, we know that the area of it will equal the total distance travelled, which is 100. So let's look at this parallel side. That will be the whole time of the race, which we know already is 27.5. And then we need to add the other parallel side. Oh, sorry, I should also just put half first like I did last time. And the other parallel side is this one here, which is the whole time of the race minus the first part, which is t. So that's 27.5 minus capital T. And then that's multiplied by the height of the trapezium, which is t, which we learned from the fact that the gradient was 1. So that's times by t. Multiply across gives me 200 is equal to 55 minus t times by t. And then we can multiply out to get 55t minus t squared. And then we can bring it all over to one side to get the following quadratic. And then when we solve that, we get a t value of 3.915. And the other t value that comes out of that quadratic is just too big, so we can just reject that one. Okay, great. And then let's finish off with the final part. So part D. It says find the difference in the speeds of the two children as they cross the finish line. Well, that's relatively straightforward because it's just the difference here, and that is just the difference between 4 and capital T. So it's going to be 4 minus 3.915, which is going to equal 0.085 meters per second. Perfect. Okay, we've got some unit vectors I and j, and we've got a particle. It's got constant acceleration, and we know its starting point, and we know that it is traveling with this speed. We're asked to find its positional vector after it's first observed. Okay, so we can use the formula that the positional vector is the starting point plus the initial velocity times t, and then plus a half a t squared. So this is going to give us the starting point, which is minus 20i minus 15 over 2j, and then plus the initial velocity, which is 4i plus 2j times by t, and then plus a half of the acceleration, which is 1/10 I minus a fifth j times by t squared. Okay, now let's go to part B, and it tells us that we need to find the times at which it is due east of the origin. So if it's due east, then that means that the positional vector has a positive I component, and it has a 0 j component. Okay, so let's look then at the j component first. So these are the j values. Okay, so let's look at the j components then. So we have minus 15 over 2. We've got plus 2t. We've also got, actually I forgot to add the half is obviously going to be part of the j component as well. So that's a total of minus 1/10 t squared. And we want that to equal 0. Okay, so let's multiply through by 10. That gives me minus 75 plus 20t minus t squared equals 0. Rearrange that like so. And then we can factorize that. And what does that give us? That gives us t minus 5 and t minus 15. Okay, great. So that gives me t is equal to 5 and t is equal to 15. Then again, we would need to check to make sure that the t values there give us a positive I position. So you would substitute in t is equal to 5 into the position, into the I value. So that would give you an I position of 5 over 4, which is positive, which means it is to the east, which is good. And you'd sub in this one as well, and that one would give you 205 over 4, which again is positive, so again it means to the east. So the answers are t is equal to 5 and t is equal to 15. Those are the two times. Perfect. Okay, part C, it says determine the speed when it is travelling in a southeasterly direction. Okay, so we need to look at the velocity, and we know the velocity is equal to u plus at. So the initial velocity is 4i plus 2j, and then we're doing plus 1/10 I minus 1/5 j multiplied by t. Okay, so let's split this up into i's and j's. So for I, we've got 4 plus 1/10 t. So that's the I. And for j, we've got 2 minus 1/5 t, and that's the j. Okay, now how do we know if it's travelling in a particular direction? And this is really important. If it's travelling in that direction, then it means that the ratio of i's and j's, that we can figure out what that is. So southeast is down here. So that's the same as having, for example, like 1i and minus 1j. That means in this situation, the j's divided by the i's, if we're travelling in that direction, the j's divided by the i's will be minus 1 divided by 1, so it'll be minus 1. Okay, so let's do that for our velocity equation. If I do the j's divided by the i's, then that should equal minus 1, because it'll be in the same ratio. Okay, so multiplying up, like so, gives me minus 4 and minus 1/10 t. And then multiplying everything through by 10 gives me 20 minus 2t is equal to minus 40 minus 1t. So that gives me that t is equal to 60. Okay, great. Now we need to find the speed. So what I'll do is I'll just put that into the velocity equations and then take the magnitude of the two components. So at t is equal to 60, we will get 4 plus 6, that will be the I, and we will get plus 2 minus 12, that will be the j. So that will be 10i minus 10j. So the speed is the magnitude of that, so it's 10 squared plus minus 10 squared, and that gives me a value of 10 root 2 meters per second to the minus 1. Okay, next one, variable acceleration, and we have a equation for the velocity, and it's asking us to find the force F. So force and acceleration are linked, so we need to find acceleration. And the acceleration is the derivative of the velocity. So this will give me 10t minus 3t squared I plus 6t squared minus 8j. Okay, and we're actually interested when t is equal to 2. So let's say t is equal to 2. What's the acceleration there then? So subbing in 2 is going to give me 20 minus 12i plus 24 minus 8j, and that will give me 8i plus 16j. Okay, great. So we know that F is equal to ma. So if we're looking for the force, then we need to do the mass, which is 1.5 multiplied by 8i plus 16j, which gives me a total of 12i plus 24j. Okay, perfect. That's that part done. Let's now look over at part B. At time t equals 0, p is at the origin. Find the position vector of p relative to the origin at the instant when p is moving in the direction of the vector j. So that means it's either going directly up or directly down. In fact, actually it means it's going directly up, isn't it? Because it's just j, which is north. Okay. So when we're going directly up, it means we've got no velocity in the I direction. So it means velocity in the I is equal to 0. And what is the velocity in the I? Well, it's this equation here. So we need to set that equation equal to 0, which gives me this. We can factorize out a t squared, like so. And we get that t is equal to 5. Note that t is equal to 0 is also a solution, but at t equals 0, it's not moving because that's the start of its journey, so it's not actually moving at that particular instant. So t equals 5 is the one to go for, and it says find the position vector. Okay, so position vector is the integral of the velocity with respect to time. So integrating that velocity equation, I'm going to t squared goes up to t cubed and then divide by 3, so 5t cubed, and then that is t to the 4 over 4. So that's the I done, and then the j is a half t to the 4, and then that will be minus 4t squared. And that is the j, and then of course plus c, don't forget the plus c. So we're going to need a bit of information to find out what c is, and that comes in the form of at t equals 0, p is at the origin. So that tells me that c is 0 straight away because it's at the origin, so the position vector is 0i plus 0j at the origin, and that's equal to our integral blah 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 plus c. And when we sub in t equals 0, then, well, you can see here they've all got t values in, so that just goes to 0, so it just means that 0 is equal to c. So because it goes through the origin at t equals 0, it means there's no c constant. Okay, great, so we can just cross that off. And what do we do now? Aha, we have the time, we sub in the time, don't we? Yes, we do. So we sub in the time. I'm not going to bore you in doing that. So when we sub in t is equal to 5, we get 625 over 12i plus 425 over 2j. Perfect. Okay, projectile question. Now, I always start my projectile questions the same. I'll write for the horizontal S, U, V, A, and T, and for the vertical, I'll also write S, U, V, A, and T. The horizontal always has 0 acceleration, and the vertical always has minus 9.8. And this time you're given the components of the velocity, which is nice, or the initial velocity. So 6 in the I, and then 12 in the j. And what's great about is if you look at a particular point, and in this case we're trying to find the distance of AB. So A is our start, so we need to investigate this point right here. We know always that the time will be the same in both directions. Okay, so what does that do? How does that help us find the distance? Well, we know something else, don't we? We know that at that particular point, it's hit the floor, so it's gone back to where it started from in terms of its vertical position. Okay, so let's go with that one then. Then let's use s equals ut plus half at squared on the vertical. So that gives me 0 is equal to 12t plus a half a t squared. Yeah, let's use capital T. Okay, so that's factorizes, doesn't it? We could take a t out, that's 12, and a half of minus 9.8 is minus 4.9. So we get this. So over t equals 0, which we know because obviously it starts with a 0 vertical position, or 4.9t is equal to 12, and that gives that t is equal to 2.449. Okay, so now that was from the vertical. Now we can look at the horizontal, and we could do the same Suvat equation, s equals ut plus a half at squared. So that gives me s, which is actually what I'm looking for. It's the horizontal distance at the point B. So that's 6 times by t, which we know, plus, oh well, not acceleration 0 in the horizontal. Of course it is. So it's just s equals ut basically, because acceleration is 0. So we just do 6 times by the time, and that gives me 14.7 meters. Lovely. Okay. That's good. Right, part B. It says that when the height of the ball above the ground is more than h meters, the speed of the ball is less than 10 meters per second. Okay, well, first off, the speed is the magnitude of the velocity. So in order to find the speed, we'll have to do the two components squared and then square rooted. It's also important to note that because there's no acceleration in the horizontal, it means that this, the 6 component of velocity in the horizontal, will just stay the same all the way through. So it's only the vertical velocity which is going to impact the speed, essentially, because the horizontal one is just going to stay constant. So the vertical one is going to change. Okay, so let's try and find what the vertical component needs to be in order for us to get speed of 10. Well, if we had a speed of 10, then that would equal the square root of, again, the horizontal component squared, which would be 6 squared, plus the vertical component squared. So squaring both sides is going to give me this. Subtracting and then square rooting is going to give me plus minus 8 is equal to the velocity in the j direction. Okay, so that kind of makes sense. It starts off at 12, and then because gravity is pushing it down, it's going to decrease. It's going to get to a point here, let's say, where the velocity in the j is equal to 8, and therefore the overall speed is 10. And then it's going to continue decreasing, so the speed is going to decrease. We're going to get to this point where the velocity in the j is 0 at the maximum height, and then it's going to come down this way, and the velocity is start to become negative because it's moving downwards, and that will give me a negative 8 at that point there. So there is a height which goes across here like that, which we need to find. Yes, it is. Okay. So let's look at the vertical direction. Makes sense. S is the height at which we're trying to inspect, and U is 12, and we know that the velocity we want to find is 8. We want to find this point here when the velocity is 8. And we know the acceleration is minus 9.8. Time, not too fussed about that this time round. So we're going to use v squared is equal to u squared plus 2as. V squared, so that's going to be 64. U squared is going to be 144. And then we're doing 2 times a, so that's minus 19.6. And s is height. Okay, so we can rearrange that, and we can find that the height is 4.08 meters. And that is that exact height there. So that is the answer. Perfect. Okay, we've got a dynamics question. We have a rough plane, and right straight away it says tan alpha is 3 over 4. So what I do is I draw a little triangle like this. Little right angle triangle. Come on, there we go. Put alpha in the corner. So that's the opposite over the adjacent. That's a 3, 4, 5 triangle. So that tells me that sine of alpha is equal to 3 over 5, and cos of alpha is equal to 4 over 5. Okay, so that's going to be useful. Next, I'm going to want to draw on my my forces. So I'm going to draw a line down here for the weight of P, and we're told that's 2 kilograms, so that's 2 times G is going to be the component, not the component, the weight, sorry. Okay, and then what I can do is I can draw the components of those. So we're going to have this one coming down here. This is adjacent to that alpha angle. So that is 2g cos alpha. And then we're going to have this other one here coming along here, and that is opposite that angle. So that is 2g sine alpha. Okay, let me just zoom in on this. Okay, great. Next, I'm going to want to do components of that Z angle there. Sorry, Z angle, what am I talking about? That X force. It's been a long day. And then this one across there, like so. Okay, we know also that the angle in here is alpha. That's just by using Z angles, alternate angles. The orange one is opposite that angle, so that will be X sine alpha, and the blue one is adjacent to that angle, so that will be X cosine alpha. Okay, it says, show that when X is equal to 14.7, there is no frictional force acting on P. Okay, so no frictional force would imply that the forces parallel to the slope are balanced. So friction wouldn't be needed because already the forces are just balancing themselves. So that would mean that X cos alpha and 2g sine alpha will be equal to each other. Let's check to see if that is the case. So 14.7 we're told is X multiplied by cos of alpha, which was, if we just go back to how we started, yeah, that would do. Okay, cos alpha was 4 over 5. Okay, so we can work out what that value is, and it's 11.76. And then the other one will be 2 times 9.8 times by sine alpha, which is 3 over 5. And that is also 11.76. So we can say, therefore, when X equals 14.7, there is no frictional force. Okay, great. You could also just like put a frictional force in and then show that it's 0 as well. That's a perfectly valid method of doing it. Okay, right, let's go on to part B. Okay, part B says the coefficient of friction between P and the plane is 0.5. Find the smallest possible value of X. Okay, so if we reduce X, it means that it's likely that the ball might fall down the slope if we reduce X like completely. So by reducing X and keeping it in position, it means that we're going to need friction to be working in our favour. So friction needs to be working up the slope to keep it in equilibrium. Now, when we're introducing friction, then we're going to need also to know the reactional force, because we know the formula that friction at its max capacity is equal to mu r. Okay, so let's find r, which it's not trivial, so be careful not just to assume that it's the same as 2g cos alpha. If we look at all of the orange forces, we can see that r balances with x sine alpha and 2g cos alpha combined. Okay, so we could tidy that up a bit. We don't know x yet, but we know sine alpha is 3 over 5. and we know we can work out what that 2g cos alpha is, and I believe it is 15.68. Okay. So using this formula for friction then, friction is equal to mu, which is 0.5 multiplied by r, which is this, like so. And this gives me, that's 0.6 times a half, so 0.3x plus 7.84. Now, this is friction at its maximum capacity. So we're going to need it to work at its maximum capacity in order to reduce x to as small as it could possibly be, whilst keeping the forces still balanced. Okay, so the point of the matter is that the forces are still balanced. So if we look along the plane, so if we look parallel to the slope, these forces should be balanced. So the forces would be F plus x cos alpha. So friction plus x cos alpha, that's going up the slope, and that should equal the force going down the slope, which is 2g sine alpha. Okay, F, we've got a formula for that. It's 0.3x plus 7.84. Cos x is, x cos alpha is 4 over 5x, or 0.8x. And that's equal to 2g sine alpha, which we can calculate, which is 11.76. And we could tidy up this equation and solve for x, and in doing so we get an answer of 3.56. Perfect. Okay, here we've got a connected particle, classic type question where we've got a pulley, a light pulley. This one's slightly harder though, because we have it on a rough slope, and it says that when it is released it will start moving up the slope, so that means that friction is going to work down the slope against the motion. And we always draw our tensions towards each other, like so. And then we've also got the weights here, so that will be 2 mg, and this one will be 3 mg. And this one we would do a component, like so, and that will be of alpha, that will be 2 mg cosine alpha, and then we'll have this component here, which will be 2 mg sine alpha. Okay, so we're asked for an equation of motion for A. Okay, so let's go along the slope. We're going to have t going forward, and also, sorry, one more thing to add is that the acceleration is going to be acting in this direction. So always do your equations in the direction of the motion. Makes it easier, I find. So that is t, and we've got going against it F, and we've also got against it the weight of the object, which is 2 mg sine alpha. I've just spotted as well that we've got tan alpha is 3 over 5, so we could draw a triangle again, 3, 4 and 5. So that tells us that sine alpha is 3 over 5, and that cos alpha is 4 over 5. So I can swap out sine alpha here for 3 over 5. And that's equal to 2 ma. So of course we're using the formula here that all the forces added up, the sum of the forces is equal to the mass times by the acceleration. The best formula ever. Okay, and now we that's good. I mean, that is exactly what it says on the tin. That is a formula equation of motion. I could simplify it, but I'm not been asked to, so I'm not going to bother. Write down the equation of motion for B. Okay, so again, if I'm looking at the direction of motion, we've got 3mg going down, and then we've got going in the direction of motion, should I say, and we've got t going against the direction of motion, so negative, and that is equal to the mass times by the acceleration. Okay, perfect. Right, so part B is asking us to find, in terms of g, the acceleration of A. Well, So I'm going to need to sub out F here. So we know that F is equal to, because we have the coefficient of friction, so it's equal to mu r. So that will be a half multiplied by 2mg times by cos alpha, and cos alpha is 4/5. Because in this instance there's no other perpendicular forces acting on the object, so it's just its component of the weight. The orange component there will be equal to the reactional force right here. Okay, so this gives me 4/5 mg. Okay, so subbing that out for F, we get 4/5 mg in there like that. And then I can actually simplify that equation even more, because we've got minus 4/5 mg and we've got minus 6/5 mg when I do 2 times by 3/5. So that gives me minus 10/5 mg, which is the same as just minus 2 mg, and that equals to 2 ma. And then we've got the other equation of motion as well, like this, and we're going to add these, and that's going to get us to cancel out the tensions. So that gives me 3mg minus 2mg is just mg, and that's equal to 5 ma. So dividing through, that gets me that A is equal to g/5. Perfect. Okay, and then it says find the magnitude of the force exerted on the pulley by the string. Okay, so let's just zoom in on the pulley and see what forces are acting on it. We've got tension acting at this angle here, and we've got tension acting straight up. So the first thing we're going to need to do is actually find what the tension is. So let's use this formula here to find what the tension is. So it's equal to 2ma plus 2mg. So that is essentially 2m A plus G, which is 2m, and we know G is a fifth. What does it want it in? We want to sub out A, of course, so we can get it in terms of G, which is a value. So that is going to be G/5 plus G, which is 6G/5. Like so. Okay, so what does that simplify? That's 12mg/5. So that is the value of the tension. Okay, so let's look at the pulley again. We've got tension coming in like this, and that's problematic because really we just want to find the magnitude. We just want the horizontal and we want all of the vertical components, and then we can just do a Pythagoras on it. So this one will be T cos alpha coming in like this, and this one will coming up like that. That will be T sine alpha, which I'll just write in here like this. And then we've also got this tension as well coming up like that. And that one's straightforward because that's just vertical, so we can add that up when we take our components. So let's look at the horizontal components. And what do we have in total? We've got t cos alpha. Now t we know is 12 mg over 5, and cos alpha we know is 4 over 5. So in total that makes 48 mg over 25. And now let's look at the vertical components. We've got t sine alpha, which again we know t and we know sine alpha, so that will be a total of 36 mg over 25. And we're also adding on t, which is just 12 mg over 5. Okay, now 12 mg over 5 we can add to the 36 mg over 25, and that gives us 96 mg over 25, like that. Okay, so those are the two components, and now to find the magnitude of the force, what we need to do is we'll need to do the square root of the squares of each of these. Now, that's when we have these mg's there, we can just take them out and just do the components, the coefficients, like that, and then add the mg's back in at the end. So we do that squared plus that squared, square rooted, and when we do that, we get our coefficient of mg as 48 root 5 over 25, and that is the final answer. Okay, ladders, absolute classic. We need to draw as much information on the diagram as we possibly can. So that will start with the reactional force, like that. It says that it is up a rough horizontal ground, so we've got frictional force acting in this direction there. And it's a smooth wall, so we just have the reaction coming normal to the wall. I'll call it N. We've got the rod has a mass of where is it? It has a mass of 30 kg, so that's 30 g, and that acts at the center of the ladder. And then we have a person standing on the ladder 2 meters from A, so it's going to be here. So that one is 70 g. Okay. What I'll do next is I'll draw on my components, which are perpendicular and then parallel to the ladder. So I have this one here, and I'll have that one there, and then I'll have this one here, like so, and this one like this. Okay, so running out of space, but we know that the orange ones are opposite the angle, and this angle in here is always the same angle as the angle that the ladder is standing up at. So for the orange ones we'll need to multiply by sine 60, and for the red ones we'll need to multiply by cos 60. Okay, and we've also need to find the force component of N. So this one right there is what we also need to find. So I know because of alternate angles that this angle in here is 60, and because the ladder and the red force are perpendicular, then this angle in here must be 30. So that red force is adjacent to that 30-degree angle, so that is going to be multiplying through by cos of 30. Okay, I think we're good. Just also put on the distances. That was 2 to there, and it was from A 3 to there. Okay, so I mean, these questions, they always start with moments at A. that is your first port of call for the majority of these questions. The question does ask me to find the magnitude of the force exerted on the ladder by the ground. So the ground will be exerting the reactional force and the frictional force. So we need to find both of them. So that's why moments at A is very useful, because it cancels out two of the forces and it allows us to find N. Okay, so moments a day. What have we got going on? We have, let's look at the weight of the person first. That's 2 meters away. The weight is 70 g, and we're multiplying by cos of 60 to get the perpendicular force. Perfect. What else have we got going on? We've got, again, the weight of the ladder is 3 is the distance away, and the weight is 30 g, and we're multiplying that by the component perpendicular, which again is 60. And all that is equal to, am I going to run out of space? Yeah, I think I might do, so I'm just going to have to write it here. Is equal to 6 is the distance away, n, and the component is going to be cos of 30. Okay, right, I'm not going to bore you working out all of these, but basically we know everything in this equation other than n, so we can solve for n. And when we do, we get 217 newtons to the free sig fig. Okay, so now let's look horizontally, because there's only 2 horizontal forces, and because they're balanced, because the object is in equilibrium, it means that those 2 forces are balanced. So that means that N is equal to F, which is equal to 217. Okay, and then let's look vertically, and we have R going up, and the only forces we've got going directly vertically are 70g and 30g. All the other forces are horizontal forces, so they have 0 vertical component. So that's 100g. Okay, so the magnitude of the force is going to be the Pythagoras of the vertical and horizontal components acting on the ladder by the ground, which is this 100g reaction force and this 217 frictional force. And this gives me, to 3 significant figures, 1000 newtons. Perfect. Okay, next part says that the man climbs further up the ladder while he is at the point D on the ladder is about to slip. Okay, so the only difference to the diagram is that this is no longer 3 away. No, sorry, that is still 3 away. It's that the man is no longer 2 away. The man is an unknown distance, let's call it x away from A. But it does mean that the ladder starts to slip. Now before we found the frictional force was equal to 217. Now that is, the friction is always lazy. It does exactly the enough amount that it needs to do. So it's not necessarily the maximum frictional force. So the frictional force will change depending on well, the situation. So what we need to figure out is what is the maximal frictional force, because this ladder is about to slip, it means that friction must be working its hardest to stop it from slipping. So we need to find the maximal frictional force, and we know that friction max is equal to mu r. And we know that mu is 0.4, and we know that the R value, which we found before, was 100g. So that equals 392 newtons. Okay, so that is the maximal frictional force. So that's the frictional force that's going to be happening in this situation, because it's just about to slip. Okay, so because we now know the maximal frictional force. It means we also now know what the N force will be doing in this situation, because again the frictional force and the N force are the same because they're the only two forces acting in this situation horizontally, and because it's about to slip, it means it's still technically in equilibrium. Okay, so what we could do now is we could do moments at A, which will allow us to find an equation for x. Okay, so moments at A. Okay, so moments at A, that means that we have, well, I don't know how far this guy is up the thing, so we'll just call it x, and that needs to be multiplied by the weight, and the component of the weight is cosine 60. And we've still got the weight of the ladder, and that is free away from the pivot point, and that weight is 30g, and then we're multiplying that as well because we want the component of it, which is perpendicular, so that is by 60, cos 60. And that equals the 6 is the distance away, this N force, and again we've got to multiply it by its component. But that being said, we actually know the N force, don't we? We know what that is, the normal force. So it's in fact it's 6 multiplied by 392. Perfect. And once again, this is an equation now which has only one unknown. It has x, so we can just solve for x, and we get 4.65. Perfect. Okay, so the last one, state how you have used the modelling assumption that the ladder is a rod. We can say that it doesn't bend. It doesn't bend. That's the assumption that we've made. We could also say that the weight acts at a single point. Right, I really hope that was useful. Good luck in your paper 3, and if you want to see me do more applied questions of this nature, then do check out my live session that I'm doing on the weekend. Okay, good luck. Bye for now.